Alright, this is lesson 5-2, part 2, and I'm going to start off with the question that I left y'all with at the end of the first video. That was on page 80. Answer this. Using T of A and C of T, find the total cost to mow 10 acres. So the first thing we need to find is the time. So if you follow this flow chart here, we take the acres and we plug it into the time function. So that would be T of 10, which would be 4 times 10, giving us 40 hours. Okay, and then from there, once we have our hours, we're going to take our hours and plug that into the cost function. So take that 40 that you just found and plug it into C of 40. And that's going to give us 20 times 40 plus 30, which would be 800 plus 30 to give us $830 to mow 10 acres. So what we're about to do next is to make this a one-step process. We want to make it to where we can go straight from the acres to the cost. That's where we're going. We want to find a way to skip finding the hours and just go straight from acres to cost. That's what composition of functions is going to let us do. So let's take a look at the next page where we really dive into how we're going to do that. So on page 81. The graphic organizer shows an operation on two functions called a composition. So the graphic organizer it's talking about is this thing down here, by the way. Operation on two functions called a composition. Okay, so notice how it says operation here. It shows an operation on two functions. Just like the addition, subtraction, and multiplication, composition is another operation. The function that results, so the result from using the output of the first function as the input for the second. So that's what we did up here. Okay, we took the output of the first function and used it as the input in the second function. Okay, from using the output of the first function as the input of the second function is called a composite function. So notice how this is the result. You get a composite function after doing composition. And over here it kind of breaks it down. Composition is an operation on two functions. A composite function is the result of doing the composition. And I'm going to give you some things to add to this. And be sure to put this in your vocabulary chem chart that I gave you a long time ago. I might repost that as a reminder. Okay, so make sure you put these two terms in your vocab chart, and I'll give you some things to add to that in a minute. In this context, the composite function is formed by the time to mow function and the cost for the job function. The time to mow function was the T of A, and the cost for the job function was the C of T. Its domain is the input for the time function, and its range is the output for the cost function. So the domain is what you're inputting. Input is the time, output is the cost. All right? So the cost to mow is a composite function. So we're going from acres to cost now. That's what we're about to do. Describe its input and output. So we would input acres. We would input the acres, which would tell us the time, and then from there, we can skip over finding the time altogether and go straight to the cost. We skip having to find the hours altogether. That's our goal. So we will be inputting acres and outputting the cost in dollars. I should put cost there. That's what we're about to do. That's what the composite function is going to do for us. When a composite function is formed, the function is often named to show the functions used to create it. Shows the function used to create it. The cost of mo function looks like this, C of T of A. So to break that down for you, it's C of, and then inside the parentheses, it used to be T, but now it's going to be T of A. So this guy right here was the time function, told us the time. My pencil died. The T of A tells us the time. But so the way it's set up, you plug in A, it gives you T, it gives you C. So I'm going to keep reading this while I let my Apple Pencil charge for a moment. The C of T of A notation implies that A was assigned a value by T of A by the time to mo function. And if this is confusing for you, that's okay. I'm going to break it down. The resulting T of A value was assigned to a value C of T of A by the cost to mo function. So we're going to complete this table here, and I'm going to break it down some more. Just letting this pencil do its thing. So C of T of A represents the cost to mow A acres. Our new domain is the acres, and our new range is the dollars. Okay, so this is going to let us skip hours completely. That's what it's letting us do by doing this composition. So our new input is acres, and our new output is the dollars. So we have C of T of A equals dollars. When we input acres, plug in acres, get out dollars. I'm going to make this a different color. Pink. Pink and green look good together. So we're going to the next page to really talk about how to do this. Jim wants to write one cost function for mowing A acres of property. To write the cost C as a function of acres, so the name is C, function of acres means our input is A acres. He substitutes, there's the key word right there, substitutes. Another word for substitutes is plugs in, right? Plugs in. He plugs T of A, takes that T of A into the cost function and then simplifies it. So here we go. To find our cost function, or to find our cost with just acres function, substitute T of A into the cost function. So here's T of A. We're taking T of A. If you recall, T of A was 4A. That was the function. So we're taking 4A and we're plugging it into C of T of A. C of T, I mean. So I'm going to break it down for you over here as well. Recall that C of T was 30 plus 20T. So, and they're taking C of T and they're replacing the T with 4A. So right here where T used to be, that's where we're going to put pink. That's where we're going to put the 4A. So we're taking the input and replacing it with 4A instead of just T. And so from here, we end up with 30 plus 80a. And this is our new function. This is C of T of A. And I skipped writing a step here. My mistake, I'm so sorry. This should say C of T of A. So basically, where T used to be, we took the function T of A and plugged it in there. See where T changed to T of A, which is 4 of A, and then we simplified it. So this is our composite function. We did the composition to get the composite function. And this lets us skip the step. We don't have to find 4a anymore, is what this is saying. So back up here to my question about 10 acres. 10 acres. We're going to answer this question again. If I use C of T of 40 now, not 40, sorry, 10, right? If I plug in 10 now, I should get the answer we got before. 80 times 10 is 800 plus 30, and we get 830. So with this composite function, I can skip that second step and go straight to my answer. I only have one function that I have to plug it into now instead of two. Write a sentence to explain what the expression C of T of 2 means. Include appropriate units in your explanation. Well, I kind of just walked us through one right here where I plugged in T acres. So our input is acres. So that means that this function, C of T of 2, it represents the cost. So if I plugged in 2, this would give me the cost to mow 2 acres. And the output, if I plugged in 2, would give me the cost, would give me money. Okay, then I want you to answer questions 12 through 14 here. And notice that it says explain, explain. So this will be a text box answer. You won't upload a picture. And then after you answer these on the next part of the module, you'll upload your picture for the practice, which is just number 15 and then 18 through 24. So make sure you answer all 3 of these, explain them, use words, use sentences. Okay? Y'all have a good day.